Okay, what we're doing today is we're learning how to use for the first time this particular form of a periodic chart to be able to do electron configurations. And what I'm having the class do is put the blocks around each of the different blocks that we have in, I should have said lines around, each of the blocks of the periodic chart. So we have the S block, the P block, and the D block, and then the F block. And we want to be sure that we are tying together helium and hydrogen. So helium really should be thought of when we're doing electron configurations as being in the S block. Okay? And what we're going to do right now is we're going to make sure that everybody writes down this stuff down here. This is essentially what's called a hierarchy, or an organization, if you will, of how we put together the terms principal energy level, sublevels, and orbitals. And just a real quick overview here. Pell is essentially like the numbers here on the right of the periodic chart, or on the left, I'm sorry, on the left. So we've got row 7, row 6, row 5, 4, 3, 2, 1. Pretty much they act as all in the same principal energy level. The guys that are on all the guys that are on row 7 are in principal energy level 7. But you see here the D's do not match, nor do the F's. Okay, because D's are always 2 down, or F's, I'm sorry, F's are always 2 down from whatever row they're on. So if we take the lanthanide series starts out on row 6, and then we drop down here, and that actually puts them down 2 rows lower, or higher, but they're lower because they're closer to the nucleus. The nucleus in this chart would be where? At the top or the bottom? Definitely the top, you bet. Because hydrogen is the guy that has his electrons closest to the nucleus, right? As does helium. So as we go here, you see it's 4F and 5F when they're on rows 6 and 7. So it's 2 down. How about the D's? How far down are they from the row that they're on? Look at it. 4 and 3. How far down from 4 is the D block? Come on. 4 minus 3. 1 down. Okay. And so you'll see that on each row. We don't get D's until we're at row 4, and then we don't get row 4 D's. Okay? We're actually getting them in row 3. And the reason for this is it mimics the order of filling of where those electrons go as we add more electrons to an atom. So the D's are 1 down, and make a note of that. D's are 1 down from the S's and P's. The S's and P's are always the same. Notice that here, 3 and 3, 2 and 2, and 5 and 5, 6 and 6, and 7, and if we had any over here, they would also be in row 7, 7S and 7P. And there's actually a couple of atoms over here. So has everybody got this copied? All right, now I'm going to show you the most, well, almost the most difficult electron configuration to write. The most difficult one would actually, with what we have on this chart, be this guy. So it would be a little bit more, not a whole lot. But here's the most complicated electron configuration. I'm going to unveil it a little bit at a time. What is this going to indicate? We have how many in the first S orbital? Or the S sublevel, I'm sorry. The S sublevel will have how many electrons total? 2. Okay, how many will there be in the 2p? Watch, folks, this is where you're going to learn how to use this chart. How many in the 2p? Yes, 6. Okay, so 2p has 6. And how many would be in the 3s? 2. Good. How many? Oops, 2s. I'm sorry. From 2s, we got to go to the 2p. So we had that, and I didn't uncover it. There we go. And there's our 2p. So we then can go on to row 3. And when we go to row 3, we get our starting out with the 3s. And that has 2. How many in the 3p? 6. And then we're going to go to the, what next? 4s. Yeah, 4s2. And I really wanted to get this so that we had principal energy levels separated, kind of. And so let's do that. And so we got the 4s with 2, the 3d with 10, and the 4p with 6. And then we go down. We got 5s with 2, 4d with 10, 5p with 6, 6s with 2, 4f with 14, and 5d with 10, and then 6p with 6, and then we got 7s with 2, and 6d with 1. Whew. Now, guess what we get to do when we do noble gas configurations? This is awesome. You're going to like this. I'm going to circle here. That's everything we get to leave alone. We don't have to write that stuff. How do you like that, huh? Okay, so what am I doing? I'm doing the electron configuration for actinium. So, just like always, like you did on your little chart that I had you use last night, we're going to put the element, right? So the element is actinium, and what's the number for actinium? 89. Okay. So we got 89 for actinium. Now, how do we get rid of all these? Watch this. We go up one row. Okay, so we've gone up a row from where actinium is. We go up a row and all the way to the end, and we have radon. And that is the magic dude. Radon is the magic that lets us leave out all of this. Now what do we write? What's left? Yeah, this is good. 7s2 and what? 7s2 and 61, and we're done. That's called noble gas configuration. Oops. N-O-B-L-E, gas. And the noble gas configuration is a shortcut, isn't it? It's a way to get out of a lot of work. That's what it is. Noble gas configuration. So, we're going to do a few more. Somebody choose an element, and we will do a noble gas configuration. I don't care what you want. Copper. Okay, I hear copper. Let's go to copper is, come on, right up here. Now, who's going to be my noble gas? Very good. You caught on right away. Excellent. All right. How do I start my configuration? All right. Cu. What's the number for Cu? Oh, by the way, here's how you check your configuration. Actinium, or actinide, brings us 89 electrons. Yeah? And then we look up here where we have our, you could call those exponents if you like, but those are the electrons in each sublevel. And so what we're going to do is add 3. And what's the number that we get? 92. And who is 92? Wait a second. Wait a second. Oh, wait a second. Actinium. Actinium, we got to go to radon. Okay, so radon is 86. And we got 3 more to 86, not 89. 86. And 3 more would be 89. And 89 has to be actinium. Yeah? Yeah, okay. Okay, so now the next one we're going to do, you wanted to do copper. So copper is right up here, and we're going to use argon. Everybody okay with that? Okay. So we got copper with how many electrons? Let's get this up. How many electrons for copper? 29. All right, 29. And who's the noble gas? Argon. Okay, after argon, all we have to do is follow down the chart. So what we're going to do is take this guy and kind of point the way, so to speak. This is the beginning of the line that copper is on. So we start with 4s with how many? 2, okay. And then we're going to get 3d with how many? 9. Right on. Because there's 10 across the line in the D's. So let's check it out. 29 and 9, 38. And is 38 our Mr. Guest? No, it's not. Oh, 28. Oh, argon is 18. Yeah, it sure is. Oops. Where did I get 29 from? 18. Copper 29. Yeah, it is 29. 29. And then we got 2 plus 9. That's 11. Wow, not doing so well. All right, now 29. What? 18. 18 is the argon. Oh, there we go. All right. 18. Copper 29. Copper is 29. Argon is 18. Argon is 18. Okay, that's where I was in trouble. Argon is 18 and 11. Okay, that's going to give us 29. And that is the number for copper. And life is good if I can write it right. Okay, so we've got copper. Now, what else can we do? How about one of these guys down here? Huh? Californium? CF, right? Is that Californium? Okay. It was just called California. I don't really know. You could look it up and you could find out. All right? But I don't know for sure. Now let's go down here and we find Californium. As we follow it back up. Now watch this. I'm following this line back up to here, which leads to actinide series. Okay? So we know that we're on row 7. And so who's our noble gas? Radon. Absolutely. Radon, because radon's on 6. Okay? So we start here after we find out what line we're on, and we did that by going down from actinium to the actinide series, and californium is in that actinide series. So now what are we going to do for our electron configuration? Who do we start with? Okay, we're going to start with californium. Oh no, we want to get the element first. Yeah, californium, CF, is it? CF, and what's our number on californium? 98. Okay, and who's the noble gas? Rn for radon. That lets us get rid of all that other stuff, right? And now we're going to go down, and from radon, we see we have 7s with 2. We've got actinium, which is in the Ds, so we have 6D with 1. And now we go down to the 5F, and how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, add them up. We got 12 here and 98. And we got 10, carry the 1, 11. Are we 110?
No.
What did I do wrong?
You did 12 plus 98 instead of 86. 12 plus 8.
Oh, 98, and there's got to be 12.
No, radon is 86. 86 plus
Oh, radon. Radon brings us 86.
86 plus
That's right. Okay, there we go. Radon brings us 86.
86 plus
86, and then we have 12 up here, and that gives us 8, and that's 98, and that's the number for California, and life is good there. Okay. Now, I'd like you all to give one of these a try on your own. We got plenty of time. We're going to get some practice on this. And we could also look at the directions. Let's look at the directions for your homework tonight. And let's get this back to single screen. Okay, the directions for the homework say to write 2 each from principal energy levels 3, 4, 5, 6, and 7. And then 2 each from the F block. I just did one for you for the F block. And then 3 randoms. So, I'd like you to pick, here, I'm going to call on someone, and they're going to pick the number. And Kathleen, you get to do this one. You can pick anything from 3, 4, 5, 6, or 7. What would you like to do? And let's get this double. 3, 4, 5, 6, or 7. What would you like? 3. Okay. Element 3? No, that's not in row 3. Anything in row 3? Anything in row 3. Okay, this is row 3. Take your choice. And by the way, row 3 would include the 3D. Okay? Sodium. Sodium. Okay, that's fine. That's going to be a really easy configuration. So, let's do sodium. And the atomic number for sodium is 11. Okay, and our noble gas is going to be, what do you say? I would like to have Kathleen do this, so give her a chance. Okay, Kathleen chose sodium. So what do you want to do? What are you going to pick for your noble gas? Neon. Good. Okay, so noble gas is neon. And neon brings how many electrons? 10. Okay, so that's our number that we're going to be adding to. After neon, what do we get next, Kathleen? Come on. The way these guys all work is you go across the line, and when you get to the end of the line, you go back to the left-hand side, next line down. So we're on row 3. So what's next in the electron configuration? 4s, good. How many electrons will be there? Come on, all the s's are the same, honey. What, 2? Yeah, you got it. All right, next, what are we going to have? Did I say 4s? She did. 3s. Okay, 3s, and now what's next? Huh? We're done. We don't have 2. You have 1. That's done. Okay? Because now the 10 plus 1 is 11. And you're good to go. That was a real easy one, wasn't it? As you can see, your homework is not going to take you very long. All right? I think that should be sufficient for our video. Thank you for watching.